This video is on section 9.3, the distributions needed for hypothesis testing. So particular distributions are associated with hypothesis testing. So here we have, when we're doing hypothesis testing on means, we might use the normal distribution if we know the population standard deviation. So we've seen this normal distribution before, where we have the mean of our original variable, but then our standard deviation is the population standard deviation divided by the square root of the sample size. If we do not know the population standard deviation, then we use the student's t distribution. So in both of these cases, the population mean is mu, and the point estimate for mu is x bar, the sample mean. If we are doing hypothesis testing on proportions, we use the normal distribution on proportions. And our mean is p, and our standard deviation, is the square root of p times q divided by n, our sample size. So in this case, the population proportion is p, and the point estimate for p is p prime. And remember, p prime is equal to x divided by n, where x is the number of successes and n is the sample size. So hypothesis test for a single population mean using a normal distribution. This is often called a z-test, because remember we use the z-score. In this case, our data should be a simple random sample, or from a simple random sample. The population should be normally distributed, or our sample size is sufficiently large. And we know the population standard deviation, which in reality is rarely known. Hypothesis testing for a single population mean mu using the student's t distribution. This is called a t-test. So again, simple random sampling. The population should be approximately normally distributed. And we use the sample standard deviation to approximate the population standard deviation. If we're doing hypothesis testing on a single population proportion p, again, the data should be from a simple random sample, and the population should meet the conditions of the binomial distribution. So there need to be a certain number of n independent trials. The outcomes of any trial are only success or failure. So binomial, there's only two options. And each trial has the same probability of success, p. And then the shape of the binomial distribution needs to be similar to the shape of the normal distribution. To ensure this, the quantities n times p and n times q must both be greater than 5. So the sample size times the success probability and the sample size times the failure probability both need to be greater than 5. And that is section 9.3.